All right, Mr. Trutna, this is going over perimeter and area. So first of all, let's attack perimeter. Let's give you a definition of how to find perimeter. So perimeter, the definition of how to find perimeter. And remember, once again, you guys are going to be taking notes and you should be writing all of this down in your notebook. But to find perimeter, it's a pretty simple concept. What you're going to do is you're going to add all the sides. Okay, so the perimeter is the addition of all the sides. It's the result of when you add up all the sides. So a really easy example here would be you can see that I have two rectangles drawn, and I'm going to go ahead and I'm going to draw another shape that doesn't have four sides, so you don't think you can only find perimeter of four-side shapes, a three-side shape. And let's go up here to this top left red rectangle right here. And let's say that I tell you that the bottom side has a length of 14 centimeters, and the right side has a length of 8 centimeters. And I ask you to find the perimeter of this rectangle right here. Okay, so I want to know what is the perimeter equal to. Now, some of you might be thinking, wait a second, Mr. Trutton, I think that you've lost your mind, or you have already lost your mind, and it's really coming into the forefront now. You said to find the perimeter, we need to add all the sides. And in number one right here, we don't know how long all the sides are. We surely know that the bottom is 14. We surely know that the right side is 8, but I don't know how long the top is, and I don't know how long the left side is. But remember, I told you that the shape is a rectangle, which would mean that the sides opposite of each other are going to be the same length. So that means if the bottom is 14 centimeters, the top has to be 14 centimeters. That means if the right side is 8 centimeters, that means the left side also has to be 8 centimeters. So to find the perimeter of number one, this rectangle, you would go 14 plus the other 14. And it doesn't matter which order you add up all the sides, just as long as you add up all the sides, plus 8, and you would work that out, and that would be your perimeter. That'd be 28. 14 plus 14 is 28. 28 plus 8 is 36. 36 plus 8 is 44. So in number one, we would have the perimeter being 44 centimeters. Okay. Number two, same idea here is what happens if I told you that the left side is 11 feet and the right, or the top side, excuse me, was 25 feet. And once again, I said find the perimeter of number two here, which is the rectangle. Same idea. Since it is a rectangle, that means that if the top side is 25 feet, the side opposite of it would have to be 25 feet, which would be the bottom. If the left side is 11 feet, that means the side opposite of it, which would be the right side, is 11 feet. And then to find the perimeter of this rectangle right here, we would add up all the sides. So we would go 11 plus 25, and you could add them up in any order you want, plus 11 plus 25. You would add all those up, use a calculator if you're not sure what they are, but this would be 72. Now, don't just put 72. If there are measurements involved, such as feet, make sure to include the measurements in there. So in number two, the perimeter would be 72 feet. Okay, now let's skip down here to number three. And in number three, what I'm going to do is I'm going to give you some marks about number three. And actually, before I do that, let's see, I'm going to draw. All right, I'm just going to take this picture and I'm just going to drag it down a little bit just so it's a little bit more out of the way. There we go. All right, so number three, we're still going to find the perimeter of this triangle right here, but I'm going to give you some kind of what may seem like weird information. Along the left side, I'm going to put what I call a tick mark. Along the right side, I'm going to put what is called the tick mark, and notice that there is one tick mark along the left side and one tick mark along the right side. The bottom of this rectangle has a length of 20, and let's go ahead and make it meters. I guess M could be meters or miles. It really doesn't matter. Let's go with meters. And let's have the right side be 12 meters. And I'm not going to tell you how long the left side is. Okay. And then in this problem, I want you to find the perimeter of the shape. You know what? As a matter of fact, because I have complete faith in you guys, and because you guys are amazing math students, I'm going to make this a little bit more challenging. And I'm going to make the right side, excuse me, have not just 12, I'm going to make it 3x plus 12 meters long for the right side right here. Okay, so now I'm going to find the perimeter. So how do we find the perimeter? Well, we add up all the sides. So we're going to take the 20, which is the bottom. We're going to add it with 3x plus 2, which is the right side. And then we're going to add the left side as well. And if you're not sure what the left side is, these tick marks right here in red, they're giving you a clue as to how long the left side is. Okay, and if you don't know what these tick marks signify in a problem, what these tick marks are telling you is that those two sides that have the tick marks are the same. So they're the same length as each other. So that means if the right side is 3x plus 12, it means the left side has to be 3x plus 12 meters as well. So to find the perimeter, I'm going to go 20 plus 3x plus 12 plus 3x plus 12. Okay, and now I'm going to add these up. But when I add these up, I have to be careful because remember, when you're adding or when you're subtracting, you can only add like terms together. So in other words, you cannot add the 20 to the 3x. You cannot add the 3x to the 12, but you can add the 20 to the 12. And you can add the 3x to the 3x. So what I'm going to do is I'm going to get out my yellow highlighter and I'm going to underline the first 3x. I'm going to underline the other 3x. Those two expressions right there, I can add those two together because they're like terms. So 3x plus 3x gives me 6x. And now I could add the numerals together, the 20, with the positive plus 12, with plus 12. So I could go 20 plus 12 plus 12, and that's 44. And it's a positive 44, so I'm going to write 6x plus 44. Okay, and that would be the perimeter of number 3. All right, you cannot add 6x to 44 because 6x is a completely different mathematical term than 44 is. So the perimeter in number 3 would be 6x plus 44. Okay, so now let's move on to area. Remember, this is titled perimeter and area. So let's move on to area. I'm going to give you kind of the definition of what area is. Area is defined as the number of square, I'm going to underline that word twice because it's important, square units inside a shape. Okay? So let's start with a very simple shape that we all recognize, a rectangle. All right, and here is my rectangle right here. And I want to find the area of this rectangle. Okay, so this would be number 4. This would be example 4 here. And I'm going to find the area of this rectangle. And let's suppose that the bottom of the rectangle has a length of 10. And I'm not going to put in, well, I'll go ahead and put in measurements. Let's go 10 centimeters. And let's say that the right side of the rectangle is 4 centimeters. That means to find the area, you would take 10 and you would just multiply it by 4. So you would take 10 centimeters, you would multiply it by 4 centimeters. That means that the area of this rectangle is 40, and it is 40 square centimeters, okay? So when we say the area is 40 square centimeters, and notice what I did to get 40 square centimeters, I just multiplied the 10, which we call the length, And then I multiplied it with the 4, which we call the width, and 10 times 4 is 40. But when we say it's 40 square centimeters, what we're saying is we're saying that inside this rectangle, the number of square units that I can fit inside this rectangle is I could fit 40 squares inside this one big rectangle right here. Okay, and I'll show you an easier example of that in example number 5. So let's say, and let's go back to a rectangle again, and really today all we're going to be doing is we're going to be finding area of rectangles. All right, so let's say in this particular rectangle, the bottom side or the length has a length of 3, and the right side has a length of 2. And if I wanted to find the area of this, well, we already know how to do it. To find the area of a rectangle, you take the bottom, which is the length, which is 3. You multiply it with the right side, which is the width, that's 2. And because 3 times 2 is 6, we would get the area is 6, and then it is 6 square units. Now, I just said square units because I don't know what the units are. If the units were, say, kilometers, we would say 6 square kilometers. Okay, now, how is this derived? Now, watch how how I know the answer is 6, okay, how it was derived. If I have the length of 3, that means if I split the length into 3 equal parts that I just did, and if the width is 2, that means if I split the width into 2 equal parts, you could see, and I didn't draw them completely accurately, but you could see that inside this shape, there are 6 squares, okay? And that's why the area is 6 square units, all right? Because remember, area is the number of square units inside a shape, all right? So we have that right there. Now, let's make this a little bit more complicated in dealing with, or let's just make it a little bit more involved in dealing with the area of the rectangles. So let's say that I have a rectangle, just like that, and this is going to be example number, what are we on here? Let's see, this would be example number 6. And this rectangle, in example number 6, is divided into 4 smaller rectangles. All right, where I have a 5, I have a 3, I have a 4, I have a 2. And I want to know what is the area of the entire figure. So the area of the entire rectangle. Now, there's 2 ways that you can look at this here. Okay, one way that you can find the area of the entire rectangle, and we're going to do it 2 different ways, is that you could find the area of each individual rectangle in this picture right here. Okay, so if I went up to the top left rectangle and I said, what's the area? You would go, well, it is 5 times 4. So the area of the top right rectangle is 20. To find the area of the bottom left rectangle, you would multiply the 2 times the 5. So 2 times 5, the area of the bottom left rectangle is 10. To find the area of the top right rectangle, what you would do is you would go, okay, well, that side is 3. The left side is 4, get it? And then 3 times 4 is 12. Therefore, the top right rectangle has an area of 12. And the same idea goes for finding the area of the smaller right rectangle. You would go, okay, well, this top part here is 3. The left side is 2 because it matches up with the 2 over there. And since 3 times 2 is 6, that means the area of the bottom right rectangle is 6. So if I wanted to find the area of the entire rectangle, I could just go 20. I could add up all 4 of the areas, 20 and 12 and 10 and 6, and that would be 48 square units. So in this, if I said find the area of the entire rectangle, you could say the answer is the area is 48 square units, and that would be absolutely correct. Now, another way to look at this is, and other students have said, wait a second, Mr. Trutna, that seems like a lot of work right here. All I have to do is I just have to look at the entire rectangle. So, in other words, the entire length of the top would be 5 plus 3, which is 8. The entire left side would be 4 plus 2, which is 6. And then all I have to do is multiply the 8 times the 6, and 8 times 6 is 48. So the answer is 48 square units, which I already found out before. And they are absolutely correct. So there are two ways to look at finding the area of this problem here. Okay. But here's the issue that we could be facing. All right. What happens in number 7? If I say, okay, I get what you said in number 6. I get the two different ways that you could find area, but I want to know what's the area of this entire rectangle right here that I'm drawing here. And it's kind of like number 6, where we have 4 smaller rectangles that are inside a big rectangle, where the bottom rectangle has an area of 20. And there's a 5 right there. And the top right rectangle has an area of 24. And there is a 6 right there. Okay, so now this one becomes a little bit where you have to break it down and you have to look at it. And this is where you can't just use the entire top and the entire bottom to find the area, because I know that I have a 5. And remember, the 5 is how long it is from there to there that I outlined in yellow. That's what the 5 represents. And then the 6 represents how long it is on the left side, but not the entire left side. It's just that portion right there. That's where the 6 came from. Now, some of you are probably going, wait a second, Mr. Trutna, if the bottom left rectangle has an area of 20, and we know that the top of it matches up with up there, so that's 5, that means the left side has to be 4, because 5 times 4 gives me an area of 20. And you are absolutely correct. Okay, and that's where that 20 came from. You say, and by the way, in this top left rectangle, if I have a length of 5 and a width of 6, because 5 times 6 is 30, that means that area is 30. Okay, and then hopefully a lot of you are seeing this right here. You're going, wait a second, this top right rectangle has an area of 24. And if the left side of that rectangle, if the left side of this top right rectangle matches up with 6, so that means there is a width of 6. And if the area is 24 and 6 times 4 is 24, that means that part right there has to be 4, because 6 times 4 is 24, which was given to me. Hopefully you're following this. Which, by the way, when I go down to the bottom right rectangle, makes that part of the bottom right rectangle 4, because it matches up with what's above it right there. Hopefully you see that. And this side is also 4. And because 4 times 4 is 16, that means the bottom right rectangle has an area of 16. Okay, so that means now if I want to find the area of the entire rectangle, I'm going to add up the 4 areas. 30 plus 20, that's 50, plus 24, that's 74, plus 16, that's 90. So that means the area of this rectangle would be 90 square units. Okay, so that would be a little bit more difficult one where we have to find the area. All right, now here's where it starts to get really fun. When I give you, and this will be the last example that we're going to go over, when I give you the same concept as finding area, like number 7 or number 6 or whatever, number 5, okay, and it's still a rectangle, just like we've been dealing with, And just like we've been dealing with, these rectangles there's 4 smaller rectangles within this rectangle, but watch this. I'm going to make this one much more difficult, or maybe not. Some of you guys will get it no problem. Let's say along the left side, I have a 5 and I have an X. Okay, and then let's say along the right side, I have a 2X, and then I have a minus 7. And I want to know what is the area of this entire rectangle right here. Okay, well, you do the same concept if you're not sure, as we did in number 7, as we did in number 6, okay, where you have to find the area of each individual rectangle. So let's go with the top right rectangle. All right, so notice the top right rectangle has a length of 2x. It has a width of 5. So that means to find the area, you're going to multiply 2x with 5, and that gives me 10x. Let's go down to the bottom left rectangle. It has a length of 2x. It has a width of x. So you need to figure out what is 2x times x, and that is 2x to the second power. Okay, how did I get that? I'll kind of draw it over here so you can see it. So 2x multiplied with x. Both of those x's have an exponent of 1, and there's a 1 in front of the x. So 2 times 1, that's where the 2 came from, and then x, and remember, when you're multiplying, you add the exponents up. So that's where the 2x to the second came from. 1 plus 1 of the exponents is 2. Okay, let's go to the top right rectangle. Let's find the area. We have the top part, which is the length, is negative 7. We're going to multiply that with its width, which is positive 5. Negative 7 times positive 5 gives me an area of negative 35. Okay, and then the bottom right rectangle, we're going to do the same. The length of the bottom right rectangle is negative 7. We're going to multiply that with its width, which is x. Negative 7 times x is negative 7x. And that means then to find the area, I'm going to add all 4 of the area of each rectangle's areas, all 4 of them. I'm going to add them together. Okay, and when I add them together, I'm going to write it like this. I'm going to take the 2x squared. I'm going to add it with the 10x, which is the bottom left and top left rectangle. I'm going to add that with negative 7x. I'm going to add that with negative 35. Okay, and now I have to simplify this. But now remember, like we said earlier when we were doing perimeter, when you're adding, you can only add like terms together. So my first question is, I'm going to start with 2x squared. Is there anything, is 10x a like term with 2x squared? The answer is no. Although they both have an x in it, they don't have an x squared. How about the minus 7x? That's not like with 2x squared. How about the minus 35? No. So there's nothing like with the 2x squared. So that means my answer has a 2x squared in it. Okay, there's nothing I can combine with the 2x squared. Now let's go to the 10x. Is there anything that I can combine with the positive 10x? Is the negative 7x or minus 7x a like term with the 10x? The answer is yes, it is. They both have just an x in them. And neither of those are like with the minus 35. So that means I can combine the 10x, the positive 10x, and I can add that with negative 7x, and 10, positive 10 plus a negative 7 is a positive 3. So that means positive 10x plus negative 7x gives me a positive 3x. So I write plus 3x. And then I go to the minus 35. And there is nothing that I can combine with the minus 35. So that means at the end of my answer, I put a plus a minus 35. So the area of this rectangle, although it looks weird, is the mathematical expression 2x squared plus 3x plus negative 35. And there we go. So there is your notes that you're going to have for in chapter one on perimeter and area.